Okay, I'm going to work through some of the practice problems for you. So I'm going to do the ones that I circled. So number one, two charged particles, Q1 6.7 coulombs, Q2 negative 3.1 coulombs, are 1.2 meters apart. What's the instantaneous electrostatic force between them? This is just a plug and chug of our equation. F equals K Q1 Q2 over R squared. K is 9.0 times 10 to the ninth Newton meter squared Coulomb squared. I'm going to times this by our charges, which is 6.7 coulombs and 3.1 coulombs. And that's going to be put over our radius squared, which is 1.2 meters squared. And then I get 1.3 times 10 to the 11th newtons. And because they are oppositely charged, the force is going to be towards each other. Okay, number two. Sorry, we got a puppy, so I'm sorry that you hear him in the background. Two charges, Q1 equals 0.32 millicoulombs, Q2 0.55 millicoulombs, exerts a mutual repulsive force of 2.5 times 10 to the fifth newtons. How far apart are they? We just take our equation and we rearrange it to solve for the radius, which is going to be the square root of K Q1 Q2 divided by the force. So again, K is 9.0 times 10 to the ninth Newton meter squared per Coulomb squared. We're going to multiply it by, we do have to convert these to coulombs. So I already did that. We're going to multiply it by 3.2 times 10 to the, actually, sorry, you can't see that that's a negative, but negative 4 coulombs times 5.5 times 10 to the negative fourth coulombs divided by the force, which is 2.5 times 10 to the fifth newtons. And I get that the distance is going to be 0.080 meters. Okay, I'm going to jump now to problem 5. It says 3 charges are arranged as follows in the diagram. And so I've got a charge here of plus 1.2 millicoulomb, charge here plus 6.4 millicoulomb, and a charge here of plus 9.1 millicoulomb. And it says A, what is the instantaneous electrostatic force exerted on the 6.4 millicoulomb charge? So I'm just looking at this one, which is why I have it starred right here. And I'm going to do my equation, same equation, F equal K Q1 Q2 over radius squared, only I'm going to have 2 instances of it, right? So the first one is going to be 9.0 times 10 to the ninth Newton meter squared per Coulomb squared, and I'm going to times it by my 6 point, now I do also have to convert these to coulombs, which I already did, and I'm going to do 6.4 times 10 to the negative third coulombs, and then I'm going to multiply it by 1.2 times 10 to the negative coulombs, and I'm going to divide it by my radius squared, which is 1.5 meters, and then I'm going to square that, and I get 3.1 times 10 to the fourth newtons. Okay, so I did this one. Now I'm going to do it again, but I'm going to do 9.0 times 10 to the ninth Newton meter squared Coulomb squared, and I'm going to times it by, again, 6.4 times 10 to the negative third coulombs, and then I'm going to multiply this by 9.1 times 10 to the negative third coulombs, and I'm going to divide it by the radius squared, 2.0 meters squared, and then I get 1.3 times 10 to the fifth newtons. And so if you look at it here, I've got my one force going this way, 1.3 times 10 to the fifth newtons, and I have my other force going this way, 3.1 times 10 to the fourth newtons. And so for my total, I'm going to add these together. Now I've kind of defined this is going to be my negative 1 to the left, this is my positive 1 to the right. So when I add them together, I'm going to get negative 1.0 times 10 to the fifth newtons. And so that's going to be going to the left as I defined it. So you can say negative and then keep it that way, or you can be really specific, 1.0 times 10 to the fifth newtons to the left. I'd probably have the negative and say the left as well. Okay, so then for part B, if you were to make the 1.2 millicoulomb and 9.1 millicoulomb charges stationary and completely remove the 6.4 millicoulomb, so we just remove this one, charge, what would the electric field at the point where the 6.4 millicoulomb charge was? Okay, so you could add the electric fields from all of the remaining charges together, or because we just did part A, we just calculated the force experienced by the charge placed at that point. So we can use that information to then calculate the electric field. So that's how I'm going to solve for it. So I'm going to do E equals F over Q naught. And so I'm going to have negative 1.0 times 10 to the 5th newtons, which I just calculated, right? And then that's going to be over 6.4 times 10 to the negative 3rd coulombs. And it's going to give me negative 1.6 times 10 to the 7th newtons per coulomb. And because it's negative, we know it's to the left. So that's the easier way to solve for that. Okay. Now for number 7, it says, draw the electric field generated by these two stationary charges. Okay, so I have my positive charge here, and I've got my negative charge here. So just know that when you're drawing electric field lines, the lines go out of the positive charges and into the negative charge. In this case, the negative charge is twice as large as the positive charge. So it's going to have twice as many lines going into it as the positive charge has going out of it. That's pretty much all you need to know. Then it also says, if a negatively charged particle were placed in this field, in which direction would it travel and where would it experience the greatest acceleration? So a negative charge placed in this field is going to travel opposite the field lines, okay? And it's going to experience the greatest acceleration between the two charges nearest the negative charge. All right. And then lastly, we're going to do 10. It says the second orbit for the only electron in a helium plus ion has a radius of 5.29 times 10 to the negative 11th meters. What is the speed of an electron in that orbit? Remember, a helium ion has 2 protons, each with a charge of plus 1.6 times 10 to the negative 19th coulombs, and 1 electron with a charge of negative 1.6 times 10 to the negative 19th coulomb. The mass of the electron is 9.1 times 10 to the negative 31 kilograms. Okay, so we're just going to do our equation, mv squared over r equal k q1 q2 r squared. And then when we rearrange for v squared, we get k q1 q2 r over r squared m. We can go ahead and cancel out one of those r's, which gives us k q1 q2 rm. And then down here, we're going to take the square root of that to go from v squared to v. So our numbers are k, 9.0 times 10 to the 9th Newton meter squares coulomb squared. And then we have 3.2 times 10 to the negative 19th coulombs. Why do we have 3.2? Because it tells us it has 2 protons, and these are each of the charges, so you multiply that by 2, and then times the charge of the electron, 1.6 times 10 to the negative 19th coulombs, and then we're going to divide it by the radius, which it tells us right here, 5.29 times 10 to the negative 11 meters, and then times the mass, which it tells us right here, 9.1 times 10 to the negative 31 kilograms, and we work that out. We get V is 3.1 times 10 to the 6 meters per second. Hopefully that's helpful for you guys. Okay guys, I wanted to go over the review questions for module 13. So question number 1 says, the 3 particles that make up an atom are the proton, the neutron, and the electron. State the electric charge for each. Don't worry about the magnitudes, just give me the signs. Okay, so you know this from chemistry, but the proton is positively charged, the neutron has no charge, and the electron is negatively charged, okay? Number 2, matter is made up of atoms and therefore has both positive and negative charges in it. Nevertheless, most matter has no electric charge. Why? Well, even though matter has electric charges, most matter has equal number of both positive and negative, right? And so because they have an equal number of both positive and negative charges, they cancel each other out. And so therefore, they have no net electric charge, okay? They're electrically neutral. Number 3, compare and contrast charging by induction and charging by conduction. Okay, in charging by conduction, you take charge from one object and you give it to another, okay? So it results in the object that you're charging having the same type of charge as the object that you started with, okay? So you're taking one, you're giving it to another, so it's going to be the same charge. In charging by induction, you're not taking charge from an electrically charged object. Instead, you're using that charge to force the same type of charge in the other object to leave, okay? So the result is that the object you're charging is going to have the opposite charge as the object you used. And that's how they work, and that's how they're different. Number 4, you have a negatively charged object and you want to give another object a negative charge. Will you charge by induction or conduction? So you have negative and you want the other object to have negative. So you're going to do that through conduction, as explained in the previous question. Number 5, what is the difference between insulators and conductors? In general, in which class do metals belong and which class do non-metals belong? Okay, conductors allow charge to move freely within them, while insulators do not. So metals are generally good conductors, while non-metals are generally not. Okay, number 6, in an electric field drawing, what is the significance of the direction in which the arrows point? Okay, the arrows point out in the direction that a free positive charge would move if it was placed in the field, okay? While a negative charge moves opposite of the direction pointed out by the arrows, okay? Number 7, in electric field drawing, what is the significance of the density of the electric field lines? All right, so the density of the electric field lines is proportional to the electrostatic force that a charge placed in the field would experience. So the more dense the lines, the greater the force that would be experienced by the charge placed in that field. All right. Number 8, 2 positive charges are placed near each other. If the charges are free to move, what will happen? How will the force that they exert on one another change as time goes on? All right, well, you know that like charges repel, so the charges are going to move away from each other. As they move away from each other, the distance between them is going to therefore increase, okay? So it means that the electrostatic force between them will decrease as the distance increases, okay? Number 9, a physicist is doing some experiments on charges. She measures the electrostatic force that exists between 2 charges. In her notebook, she writes down that charge 1 exerts a 1001 Newton force on charge 2. What is the magnitude of the force that charge 2 exerts on charge 1? So in electrostatics, charges exert a mutual force. So that inherently means whatever force 1 is exerting, the other is going to exert a force of equal magnitude, but it's going to be opposite direction, okay? And that's because of Newton's third law. So charge 2 is going to exert a 1001 Newton force on charge 1, okay? Equal but opposite direction. Number 10, 2 charges are held in place close to one another, and the electrostatic force that they exert on one another is measured. If the distance between the charges is then doubled, what happens to the magnitude of the force? Okay. As the distance increases, the force is going to decrease, right? Also, the distance is squared. So if the distance increased by a factor of 2, and looking at our equation 13.1, where we're looking at the denominator, right? It's increasing by a factor of 2 squared, or 4. So therefore, our force is going to decrease by a factor of 4, okay? And look at equation 13.1. That should make sense to you. Okay, guys, hopefully you found this helpful. Remember, we are not meeting next week due to the eclipse. You need to submit your test 13 to me by Monday the 8th at midnight. You also need to submit your at-home quiz to me by Monday the 8th at midnight, and continue reading. You're supposed to have read the first half of Module 14. I haven't figured out yet if I'm going to have time to do a video for you, or when we come back on the 15th, if we're just going to do the whole module then. But either way, you are responsible for having the whole module read by the 15th, either way. Let me know if you have any questions, and I'll see you soon.